I'm Adam Baldwin. Not the actor Adam Baldwin, although sometimes gets confused on Twitter. I work at a place called And Yet, where we make software for human people, where I lead the Lyft security team, and I get the pleasure of trying to break all of the wonderful software that you build in an effort to, better the world, right? So I also started and organized the Node Security Project. And that's a bit about what this talk is going to be about, is the experiments that I've run over the years to try to understand the security posture of the community, of the ecosystem, of the software that we build, the software that you build, and how to make that better. And we're going to take a trip back in time to when the Node Security Project first started. This is the original logo. This is why security people do not build logos. This one's better. This one is worse. Okay, it's not a design talk. So once upon a time. So to set the stage, Node 0.4 was just released. This was about 4 years ago. And there were about 12,000 modules in the NPM registry. And Yet was building their first product on Node. And it was my responsibility to make sure that we were conscious of and addressing security concerns that came up. As I learned about the Node way, because I was new to Node, I didn't even know what this NPM thing was, and I was just getting it figured out. I came from a Python background before then. I was figuring things out. It became apparent to me that one of the biggest security challenges we would face in building our application would be that the various things that were outside of our control. We could control the code quality of what we were building, of what the teammates building. We can do that through linting and through peer review and all those other fun things. But the things that you all produce and share on NPM, that was going to be a headache for me. And every so often, it's discovered that malicious code can be hosted on NPM, right? Such as rim or fall. There's been others, even before I started doing security stuff, there was content published that maybe wasn't supposed to be published on NPM. And after they get past the fact that you have these install scripts that run when you install packages, that if you don't know about them, go understand them a little bit more at the scripts URL there. And after we get sort of past that point, what's left out and that doesn't get talked about is that you still have to get that code from NPM onto the victim's machine. And that's where it seems to get glossed over. Oh, I can post this malicious thing. Yeah, but people aren't just going to NPM install totally not a virus. Trust me that I'm a dolphin. I'll wait if you want to try that. You still have to get that code to them. So let's take a little step back and understand this is what I was doing back then. I was understanding who the actors were, who were the players there. And for me it was, you have the devs, right? You have your team, you have other devs, and you get the jerks, the people that wanted to publish intentfully malicious things on that network. And then you've got the distribution point. You've got NPM. And so there's different ways that we can go about, there's different attacks against each one of those different actors in different places on the network to get code to execute and be delivered to that victim. So the first thing I was understanding NPM, and I was understanding the NoSQL database land, and I realized that NPM was built on Couch. Well, old versions of Couch exposed all of the SHA hashes, which seems silly today, but exposed all of the SHA hashes at that time to the end users. It was just available. And to me, that was just a feature of Couch, but to me, that was a breach. That's what I consider from a security background a breach. So I had everyone's SHAs. I ran them through a GPU, and I cracked about 25% of them overnight. And that was, to me, I could now compromise those modules. This is one of those hashes. It is an exercise left up to you to crack it and tell me who that is. You'll be surprised that not everyone treats that password as something important, yet it's guarding something very important. So what's the other actors in this are the developers, that you are publishing modules on the registry, or you are consuming modules on the registry. I want to get that to you. So humans make mistakes, right? Humans type things poorly. We make typos when we install things. So another sort of experiment that I did, and I'm going to be all over the place. I've always wanted to give a talk where I can just talk about all of the different sort of research things that I've done. So I get this opportunity to do that. So if anything's confusing, see me afterwards, because I'm just going to be all over the place. Typos. I got all the web server logs from Isaac way back when. And I wanted to understand, do people understand what they're supposed to be installing? And what I found from those web server logs was that people would do things like npm install fs, npm install http, npm install buffer. Some things, those are valid for if you want to browserify things and whatever, but some of those aren't taken. They're just available, and you could put something there that may be malicious. So what I did instead was I took the top 100 modules, I generated typos for them, and what I found was that punctuation causes error. Those are the ones that rose to the top, being most attempted to be installed, but didn't actually exist in the registry. And so is it socket.io or socket.io? Which one are you actually supposed to install? And do you type that right every single time? Is it CoffeeScript or Coffee-Script? It's actually Coffee-Script. I published CoffeeScript just to see what, if anyone would notice. And it didn't do anything. It was a README that said, if you find this, let me know, and I'll take it down. It took about a week and about 200 downloads or installs for somebody to actually finally recognize that this wasn't supposed to be there, to contact me and the registry, and it was taken down. So that's a pretty good community response. But would that have been noticed had I mimicked the behavior of CoffeeScript and I just put in whatever I wanted to there? I'm doubtful that it would have. So what's next? What's stopping me from publishing modules as you, right? If we don't find a flaw in the registry, this is a big one. And passwords. Passwords are currently what stops me from publishing as you and being you on NPM. And what's interesting is who's changed their NPM password within the last, say, 30 days? Rebecca, maybe? We don't. It's put in we get an auth token and it's put in a configuration file. We don't have to. It's a convenience, right? It's gone. It's out of our hair, and so we don't change that. And maybe there's users that have set up accounts that don't have good passwords, right? And so what I did was I looked for some accounts with poor passwords, and I'm not going to tell you what they were, but we're going to talk about. We are going to do a little side track and look at some visualization of that. So let's run this, and it's going to be messy and ugly, and we're going to make it bigger so you can see it, I hope. Come on. So that's all further I can zoom, sorry. Well, we'll move around. So what I did was once I got all those accounts, and I wanted to see what impact did those accounts have, because they weren't just all test accounts. There's a lot of test accounts. These are these little one-offs where that's the little red dots, the maintainer, and the little green dots, the packages that they control. When you start visualizing and start looking, you start seeing these clusters. This person has a lot of packages. They might be test packages. And then you got other ones over here. A few other test packages, interdependent there. And you got this one down here. That dependency tree, so one user in NPM with a poor package or poor password that you use their module, you're accepting their security standards, right? So this person has packages that extend well up into other projects. And so it's important to rotate those credentials. It's important to take that on if you're a module author, to be rotating that and taking your account security seriously for everyone else that is using your modules. Let's see if this works. Okay. So, I made a claim when I started the Node Security project that we were going to audit all of the things. This was the big claim that I made when I started the Node Security project, because I said, okay, we've got this playground, we got this self-contained thing where all the code's being published and shared. I can just skip through it and find bugs and help people fix it. Well, there's 12,000 things in the registry at that point in time. Now there are this many. And I look like that. And the reason I look like that is because security is like this. This is security. And this is what happens when you're publishing. I think you all are publishing like 2,500 modules a week or something like that. We can't keep up. It is impossible for us to keep up. Security, it's a journey. It's not a destination. It's like the Penrose stairs. You will be this little person forever and ever and ever. And that's what we are. That's the Node Security project. I can't meet that claim of auditing all the things for all the things. I will never, ever meet that claim. I'm sorry that I ever said it, and I take it back, and we will just move on. This is my moving on from that. However, we can audit for things, and we can keep up, and we can tell you about them. And so we are going to be doing that better. Right now, all you see is the negatives. You see the Node Security project publish advisories of things we find. So, but how are we doing that? How are we looking for certain things? So how do I look for things and find vulnerabilities in the NPM playground that it is? That's through static analysis, right? We're not doing dynamic analysis. We're not running all of this code. We're just, grep is my friend. I'll admit it. I use grep more than I use any other tool for finding bugs in your software. And but let's talk about what that process is for just maybe one thing. So first of all, we put on our thinking hat and we identify a pattern. So where do we find these patterns? We steal these patterns. I'm a pink hat hacker, by the way. We steal these patterns from other languages. We say, okay, what are some bugs in Python? What are some bugs in Ruby land? What are some patterns? And we steal those, and then we just look for them, right? And then we search for that pattern. And searching for that pattern is hard. That's my daughter searching. And the thing is that it's hard to search with something like grep. You don't have context. You get a hit, and it's a hotspot, but it's not really good enough. And then you have the challenge of, now, what's interesting is you all in your code can apply these things really, really, really simple and really fast to your code bases. When we're taking it to the NPM scale, it's really, really hard. So some of the challenges you have to deal with is storage requirements. It's like 500 gigabyte on disk. There's 1.2 million plus tarballs in NPM, right? Like that's a challenge in and of itself. You have to deal with people checking in, like it used to be node modules in there and test directories. Modules like your mom, which is like a 200K tarball that blows up into 8 gig file. It's going to blow up your processes. You just end up blacklisting those. Argument too long. You're gonna. This is where we started. We started with really janky systems. What we have now is we've got a clone of NPM in S3, and whenever a tarball hits S3, it triggers Lambda jobs, and that we can actually do that automatic analysis, and it just brings it up to a human level. It tells us, here's a hotspot, here's where a human should go look and validate. It's just a little bit better than grep. So once you've found your hotspot, right, you need to validate, and you need to make sure that the thing that you're testing, can you actually abuse it? This is my son on a rocking horse riding down this thing on a skateboard. He's using it as it's not intended. We need to validate those things. And auditing modules is really unique because what do we claim as a vulnerability? You can use a module as it wasn't intended, right? But so the metric that I use, and this is how, when I'm auditing a module, I say, is the module making a promise that I can break? For example, the Markdown module has a sanitize true option. And when you set sanitize true, it says that the output is going to be safe for a browser environment. It makes a promise. And we have a number of times violated that or been able to break that promise, and that's advisory worthy. Otherwise, it's just misuse, and maybe it can create a security situation, maybe not. And then the most important thing that I can tell you about searching for vulnerabilities is, I guess the best way to tell you is, have you ever seen a cat try to get into a box? How about a box like this big? It still tries to get into that box. It will repeatedly bang its face against the entrance of that box until it gets in, or maybe gets sidetracked and walks away. But curiosity and actually trying to find bugs in your code that are related to security is the way you're going to do that. I don't care what knowledge you have, what background, whatever, as long as you go and you try and you learn about them and you go look, you actually do that act of looking and having that curiosity, you will find those bugs in your code. So here's some fun stuff that may help you. Here's some ESLint rules that we're going to release today that deal with security patterns. So we kind of improved our game from grep. We said, hey, grep kind of stinks. Let's get a little more context. Let's use the AST, and let's use the tools that we have. And so there's a few of them that try to find unsafe regular expressions, and then different sort of patterns that we've found very common in code. They're not that great. Don't add them to your project and expect your linting to pass, because they're going to find a bunch of false positives, but it tells you as a human where you might look, and you might find something. If you want to put NPM on disk and actually have it, I made a little project. I've got a little hard drive that I keep NPM on me at all times just for spelunking. It's fun. You can use, it's based on registry static by Dave Glass, just for local testing, if you want to actually attempt that. And the other thing now is, where does that data go? When we find something, I found that not many people know about this, so we publish all the advisories of things that we find that get reported to us at nodesecurity.io/advisories. And you can consume that in your project with a really, really nice tool called NSP. And you can just install it, run NSP check. It's going to tell you if there's a dependency or dependency of a dependency that has a flaw in it. The other thing is once we have all those modules and we have all that data, we can just run other tools against that, right? So one of the things I did, there's a tool called RetiredJS. It's very similar to NSP, except it's got a catalog of more like front-end framework vulnerabilities. This version of jQuery is known vulnerable to this type of thing. And you should be using it in your code. So we ran it against NPM back when there was about 184,000 modules. And we found that about 1.6% of things had known flaws. And so we're going to start to expose that through the Node Security Project, but that's something there. You should be looking at your project. Not real that exciting. It's needle in a haystack, right? The majority of the projects don't have those libraries. And a good portion of these things also are probably in test directories, example directories. This was of Bower. So Bower's more focused on front-end frameworks, and I believe Bower is, since kind of slowing down in development, probably see some of that shift over to NPM. You see a larger percentage because they're just focused on that type of, that's the audience, right? And then we did some interesting things with just Bower and static analysis. There's a tool called Burp Proxy that has a built-in static analysis engine. It can do taint checking to see if certain sources, user input from, say, a query parameter, ends up in a sink, such as like window.location or into the DOM and things like that. And this is what we found for Bower. We found just a pile of interesting vulnerabilities, potentials. I published that data there. We haven't actually looked through it and validated any of it, but if you're doing projects that you have exposed on Bower, you can go splunking through that data and maybe you'll find something of interest to you. If you do find something that's a validated, confirmed vulnerability, please let us know, and we'll publish an advisory in your name. This is a fun one. I thought, who else is out there in the ecosystem doing stuff in NPM? Who else might be doing this stuff that I'm doing? And I wanted to find out if there's any robots pulling stuff down, testing it, installing packages, maybe a CI, maybe something. And this sort of failed horribly. There's not really anything out there doing anything like this. I created a module called botbait, and it calls home. That's all it does. When you test, calls home. When you start it calls home. When you install it, calls home. When you run index, you require it, it calls home. That's all it does. It sends your Node version to me. One person installed it. That's it, or one process, one bot, this lonely soul in Portugal. I don't know who you are, but thank you for installing it. And it was downloaded 165 times, which is interesting. So people are cloning this data. They're just not necessarily running npm test or npm install. So that's kind of interesting. So that's kind of the history. Those are the things that we've done to find stuff in npm. That's it. That's pretty much all the different experiments. I mean, there's very, like, those greps take, 2 to 3 hours to complete. So, there's a lot of run a pattern, come back, run a pattern, go over, 12,000 lines of output, things like that. So now we're trying to do that. We're trying to do that faster. We're trying to do that more accurate. We had an intern this summer build a static analysis engine for us to do really, really good taint checking. So we can load AST and we can do control flow graphs and we can do data flow into Neo4j. And we can query it like Facebook does Facebook friends, right? And we can find vulnerabilities that way. And that's pretty interesting. And I'm going to talk about two things that we're doing now that I found kind of interesting. So what about finding malicious modules? What about modules that are, say, like the CoffeeScript module, but they actually have malicious behavior on install, just like the rimrefall module? How might we be able to find those in the registry? So I started a project, and it's available here at nodevember.evilpacket.net, and it is a search. Okay, cool. That's not what I wanted. So it is a search engine for what a module does on install. So you can put, say, happy in here, and please actually work. Of course, I'm probably not online. That's great. Well, you can play with it, and yeah, my internet doesn't work. So, failed live demo. It lists out any files that were added, changed, or deleted for that Docker container. Docker's got this really, really nice feature called Docker diff. You run a container, you run a diff, you see what files changed. It's really interesting. And I plan on, you can see kind of right here. Not really that exciting. This is just what it shows. But if you see, that's for rimrefall, it just deleted a bunch of files. It touched Etsy. It touched var. Why would a module do that? I can see that. It's about 56 gigs of data right now, and it's open. You can go search it, and we'll expose it at some point through the Node Security Project. And then the last one I want to talk about, and hopefully this live demo doesn't fail miserably, is we're doing fuzzing of binary modules. So fuzzing, basically taking, there's a tool called AFL Fuzz, American Fuzzy Lop, and it's really useful for fuzzing C-based applications, things like that. And it employs like a genetic kind of algorithm, so it finds ways to get new code paths. It instruments the code, and it sees when it goes farther, and it tries to snake that input farther and then try different types of input to crash the application. This was message pack 0.2.6. It's since been fixed. It used to crash when you just gave it. We're gonna try run on Node SAS and see if we can find any bugs. I'm gonna give it about 30 seconds, and if it fails horribly, then we will just kind of move on. But what we've done is we built a little sort of like harness, a Docker container and a harness, and that builds Node. And my coworker John Lamandola has sort of like pushed this really hard, trying to get instrumentation of these binary modules. There's not very many, but some of them are pretty important. Bcrypt and bson, and there's a lot of important ones out there that we want to fuzz. And so let's just build this Docker. Okay, come on. We'll build a Docker image quick, and that's going to fail miserably because it can't find the hashes. Yeah, Docker images. Oh, you got to be kidding me. Why is is there no internet? Well, that's, oh, there we go. So, let's do, that's way too small. Okay, so let's see, root, this is a fuzzer, and we basically can start the fuzzer, and of course it's going to try to install npm install, which you can't do. So what it'll try to do is it tries to build with these options. It's instrumenting the binary module. And of course it's not there. This is going to fail miserably, and I didn't record this one. So watch me flounder. If I had network, it's like it worked 15 minutes ago. Why does the Wi-Fi not work? What's that? Just, of course, it works on my machine, right? Let me just do this, because if I've got time, this is really fun. And we might just find an ODE in Node SAS. Okay, well, that works apparently now. Okay, let's not send our output to dev null. So what it's doing now is basically it's might be kind of hard to see. Basically what it's doing is running about just 12 exec per second. It's calling a very small script. It's taking user input, compiling it with Node SAS, and that's it. That's all the little app. It's all the little program does, and it needs input actually to crash. So let's try that again. It's generating input. It's mutating it. It's doing arithmetic, bit flips, things like that, and it's sending it to the app and then seeing if it crashed. And it shouldn't take too long. So this path number right here, it's finding new interesting ways. Oh, I covered it up. There, we got a crash. So we've got a way. If you have an application that takes user input in Node SAS, we can crash it. That's it. That's what we can do. And so we can take that now. We can look at that test case. We can provide that to Node SAS and say, here's how you could, here's how you can make things better. And we hopefully are going to be able to do that for any Node binary add-ons out there. It's really just setting up that build environment. So with that said, that demo didn't fail too horribly. And that's basically it. We've gone through and we've done a lot with different experiments. We've just taken our knowledge in security, and we've taken our knowledge of the Node ecosystem. We try to apply them together and make things better for you. What I want you to get out of this is that you can do that too in your code base. It takes curiosity. It takes looking to other sources like other languages. It takes doing a little bit of research and a little bit of splunking, and you might find something. NPM is a great playground for that. As well as your own code base. If you see something, say something. I mean, if you find something, report a security issue to us, and that's what I got. Thank you. And now we're up to 6 crashes. And this one over here has been running overnight, and it's got about 168. Slides are not online yet, but they will be. And I don't know if we got a few minutes it's probably about time, but if you got any questions? Heckles? Cool. Well, that's it. Enjoy. This should work now. Maybe not. Enjoy the tools. Enjoy NSP. If you have anything, suggestions, send it to us, and that's it.